As promised, we are going to look at an investment and a growth and decay problem. The question is sent to us by Mbali Kubeka. So Mbali, thank you for this question. I specifically chose this one because of the interesting investment that we're working with. I'm going to read it for us. NOMSA started working on the 1st of January 1970. At the end of January 1970, and at the end of each month thereafter, she deposited 400 Rand into an annuity fund. She continued doing this until she retired, which was on the 31st of December 2013. Now, folks, if you work that out, she worked for what? 30 plus 43 years working life. Okay, and then she did this monthly. Okay, so let us write down what we have. We've got that she deposited, so it's a regular deposit. So I'm going to indicate this with an X, which is equal to, what's happening with my pen? X, which is equal to 400. Okay, my board is hanging, folks. Let us read what the... Okay. Oh, there we go. There we go. We're back. We're at 400 Rand. Okay. Per month, and she paid at the end of the month. Okay, so that was for... Remember, this was what? What now? I forgot how many years? 43 years. Okay, and 43 multiplied by 12, if my grade 4 math stands me in good stead, we have 516 of these monthly payments that she made. Okay, now, the first question is asking now, please folks, be careful. They're saying, how much money did she pay into this investment? They're not asking for the future value of this investment. They're asking how much money was paid into the investment. And that's the simple answer. It is 516 multiplied by 400. And that gives you a total that she paid in of 206,400 Rand. Okay, so that's a lot of money if you think about this. If you pay 400 Rand a month at the end of 516 months, you've got 206,500 Rand. Okay, that's a lot of money. Now they say, the second part, the interest rate in the fund that she paid this money into, the interest rate here was a beautiful 8% per annum compounded monthly. Now again, we've got this problem. Our stated period and our compounding periods are different, so we have to take I, get it to I, so we're going to take 8 and divide it by 1200, and what do we have? 0.0083, another recurring decimal. But folks, you have to make sure that you do that. You may not work with a nominal rate. You only work with effective rates per period, whether the period is months or whether the period is quarters or years. It's got to be the same thing. Okay, now they're asking us, calculate the value in the fund at the end of or when she retired. Okay, now that clearly is a future value. She paid this money into an account, she saved it up, and she retired. So our future value is going to be the 400 that she paid in monthly, 1,0083 recurring, remember your decimals, the period is 516 minus 1 divided by 0,0083 recurring. Now again, this is straightforward calculator work, folks. When you punch all of this into your calculator, you get 178977,22. Now, folks, I think now you will understand how important it is to save. Mbali, this question shows it to you. She only paid over 206,000. Look at how much she has today. When she retires, 1.789 million. That is a lot of money for just saving 400 Rand a month for the 516 months. Okay, so that is how much she has in her account when she retires. Now the question takes a different route, and this is the route that I love. It says, on the 1st of January 2014, Nomsa invested 2 million. Okay, so the present value of her investment here is 2 million into an account that pays interest at, now the interest is 10% per annum compounded monthly. Now again, our usual route, I has to be divided, 10 has to be divided by a beautiful 1200. Okay, now that, let me just see here. Yeah, we have this now as our effective rate that we're going to use in our annuity formula. Okay, if we calculate that with our, sorry, I must finish reading the question. If Nomsa wishes to make monthly withdrawals, so she wants to withdraw X Rand per month for a period of 25 years. Okay, now 25 years will give us a 300-month period. Okay, but look at what's happening here. She's taking her future value, the 2 million that she is investing. Different problem. She's taking the 2 million, she's putting it into an account, and from that account, she wants to withdraw X Rand a month. Okay, T2, T3, and she wants to carry on doing this for 300 months. Hopefully there's enough money in there for her to have when she retires. The question now asks us, what is the maximum value of the money she can withdraw? Okay, so we want this. X is what we're asking ourselves to find out, and we have our present value over here. So this is an investment account. That's the point of the problem. It's an investment account. It's called the present value of an investment. Okay, it's a present value investment. She puts the money in now. Why? To take out money regularly. So she's investing it and withdrawing. So let's have a look. If I take 10 and I divide it by the 1200, I get my 0.0083. Remember, that recurs beautifully for the whole period. So every time you use it, you put that into your calculator. And then it's a simple present value problem. She's got 2 million. So remember, 2 million has 6 zeros. X, 1 minus 1,0083 recurring for 300 periods divided by 0.0083 recurring. There we go. Okay, and again, a simple calculator work. You find the sum of that annuity, you divide the 2 million by that sum, and then you have your regular monthly payment of money that she can take out in 300 withdrawals. So that is 18,174 Rand and 2 cents. Now, folks, this is fascinating. She paid in her first investment 400 Rand per month. She ended up with 1.7 million. Okay? This question is 300,000 more. And she wants to take out for 25 years, she wants to supplement her pension with this 2 million that she's put into this account. For 300 months, she will supplement her income with 18,174 Rand and 2 cents. Okay, that is huge. It pays to save, it pays to put money in account. Let the money work for you and take equal withdrawals from that account every month. Okay, Mbali, that is the first part of your question. The second part deals with a growth and decay question. It says, for each period of 3 years, now the periods go from 2010 and it goes all the way to 2012. Now, for those of you who thought that was 2 years, it is not. Top minus bottom plus 1, like you do in sequences and series. So that's for 3 years. The population of town X, so there's 2 towns. There's town X and then there's town Y. For town X, the population decreased by 8% per annum. For town Y, it increased by 12% per annum. So let's put that down. For town X, the population decreased by 8% per annum. And for town Y, the population increased at a rate of 12% per annum. Now they ask us, excuse me, determine the ratio of the population of town X to the population of town Y at the beginning of the 2010 period, if at the end of 2012 the populations of these 2 towns are indeed the same. Okay, so 3 years from now, population the same. So we want the future value of this town X population and the future value of town Y. So it's the present value of town X for the future value, obviously, of town X. We take the present value, which they told us to call PX, and we decrease it 1 minus 0,08 for a period of 3 years. Now that's going to be equal to, at the end of the 3-year period, to the present value of town Y, which increased by 12. Remember, if it decreases, it's 1 minus I. If it increases, it's 1 plus I. So here we have 1 plus 12%. So the 12% divided by 100 makes this 1 plus 0,12 for a period of 3 years. Now, folks, you can see what we're looking for. The future value for X and Y is the same. So this is out of the picture. We might as well just get rid of it there. What do we want? We want to find PX over PY. The ratio of the population of X in 2010, which is PX, and over the population of town Y at the same time, at 2010. So this is simply 1 minus that gives us 0,02 to the power of 3 divided by 1,12 to the power of 3. Now, if you calculate that, folks, it's 0,554, and there's a few more decimals that comes after that. Now, if I want to change that into a ratio, I can approximate my answer. I can say this is approximately 55 over 100, which then simplifies beautifully to 11 over 20. So PX to PY was definitely, the ratio of these populations were 11 to 20. And that's what the question wanted us to calculate. The initial population, the ratio between the initial 2 populations. So Mbali, I hope that that helped you with that particular question. Remember, if you put money into an account to make equal withdrawals, you have a present value as an investment. That is what was interesting about this one. Let's move to our next question. Our next question is given to us by Monaiwa Carla. I hope I said your name correctly. It's compound interest versus simple interest. It takes the two and it compares it with one another. And that's why I chose your question. The rest of your question is something that we've dealt with already, which is a bank loan. Okay, so we've dealt with a bank loan. Let's just look at the first part. It says, two friends, Kuda and Thabo, each wants to invest 5,000 for 4 years. So let's put that down. Okay, so they want to, the present value that they want to invest is 5,000 Rand, and they want to invest it for a period of 4 years. Kuda invests her money into an account that pays simple interest. So for Kuda, the following is true. She has an interest rate per annum given as simple interest. And they say her interest rate is 8.3% per annum simple interest. Okay, now that's huge, folks. Don't forget that it's simple interest because it uses a different rule. Let me just move and make space for Thabo's information. Now, Thabo, on the other hand, Thabo's information tells us, let me do that here. Thabo is going to invest his money into an account that pays interest at 8.1% per annum compounded monthly for the same period. Now, there's a twist with Kuda's investment. At the end of her investment period, she gets an additional 4% of the accumulated amount. Yeah. At the end of Kuda's investment, his money, at the end of 4 years, will receive an additional bonus of 4% of the accumulated amount. So this here is plus 4% of the future value after 3 years for Kuda. Okay, now Kuda, they invest, both of them invest 5,000. Okay, so let's set up our problem. 5,000 Rand is invested at simple interest for 4 years at that rate. So it's 1 plus 4 times, now remember you have to divide this by 100, 0.083. Now that here will take it to a period, it's 4 years that they invest. Yeah, period of 4 years, this is the future value for Kuda. Okay, but remember, Kuda gets that additional 4%. So we can take this whole thing here and we can multiply it with 1.04. Kuda gets the full amount plus an additional 4% of this future value on this account over here. Okay, so let us see. If I calculate that with my calculator, I punch all of that in, I get 6,926 Rand and 40 cents. So we can put the R over there. So that is what Kuda has at the end of the 4-year investment. Okay, now Thabo does something else. Thabo took it into an account that paid 8.1% per annum compounded monthly. For 4 years, okay, for 4 years for Thabo, let's do Thabo in blue. For Thabo, we have to take the 5,000. We have to turn this into a PMCM, make it effective per period, okay? Or we can turn it into a normal yearly rate, depending on what we want to work with, because we've got 4 years. I think it's going to be easier to take the 4 years and multiply it with 12 to give us 48 months that this is going to happen, this investment. So what do I need to do with the R? I need to divide it by 100 to get it into decimal form, and then by a further 12 to get it effective. So the I value here for Thabo is 8.1 divided by 1200. Now folks, if we calculate that, we get this to be 0,00675. Okay, so that goes in 1,00675 for a total period of 48 months. And that gives us a total amount in a calculator of 6905,72. Now you can compare the two. The one had 6,926 kuda, and Tato had 6,905. And the clear winner here is Kuda's investment. It's a much better investment, most probably because of that last 4% bonus that Kuda got. Might have then just taken her past. We don't know. Okay, so that compares your simple interest with your compound interest.